go back, so there's a question from Zoom that is around how the controls are an indicator of viral density and contagiousness. So the question specifically is, I'm not sure how the controls are an indicator of viral density that is actually significantly contagious. Maybe they're not. If they aren't, then how should we think about the control? So I don't know if you want to go through a little, or if you want to sort of talk a little bit about that.
So in this paper, they are not addressing whether the amount of virals that they find are actually able to to have the potential contain you and to make you sick, because there is research showing that viral loads do make a difference on how much virus you get exposed. But in this case, the controls are actually not to basically prove that this virus can be transmitted to another person, but also to control that you can actually, in this individual who is sick, for example, if I'm sick and I get a nose swab, I actually find a lot of virus. So I validate first, this person is actually sick, and then you can see that when they exhale breath, you are sharing a small dose of a load of virus. This doesn't mean that it has contagious potential or not. No, it just means that the virus is out there. So in order to see the other part, you can sort of think in a follow-up experiment, having sort of like a test animal exposed to these breath particles, and then monitor the animal to see whether the animal gets sick or not. And then you can basically determine the load of virus that you need in the air in order to make this and make it a possibility. So it goes into more and more experiments that in this paper they don't address. So we are not saying that when you breathe out, you're infecting other people immediately. We're saying that you are leaving the virus there. That's it.
Yeah, I think thank you so much for that clarification. I think that's really important. Whenever we think about experimental evaluation as a style of scientific reasoning, we do have to think about, what it is that we're asking, and then interpretate the data based on the question that we're asking, and sort of like, it's hard to not jump, right? And that's a really important thing about science, is that you can only answer the question you're asking with the data that you have to represent that answer. You can't really extrapolate unless you can do a whole new experiment and generate a whole nother set of data. So thank you for that.
Exactly. Yeah. We don't speculate about everything. We first prove it, and then
yeah.
So again, question 2, this might not be something that was covered in the course of this paper. It comes from Swanid. And the question is, can a plastic reinforcement, and I guess this is one of those face shields, further prevent the ability of nasal droplets or aerosols to pass through?
So this is not in this research, and I haven't read any proper research showing that it does. But my guess is that because these are very dense polymers, that actually you are not going to be able to, the virus is not going to get able to go through it, maybe around it. And the fact that you are wearing a mask and then this shield can increase the protection that people have around the virus.
So here's a really intuitive question. I like this one. Do you know if the rhinovirus is smaller than the coronavirus? And maybe that could be an explanation around why it penetrates these masks more than the coronavirus?
So actually, yeah, the rhinovirus is smaller, and it has like a smaller coat. So the coronavirus is actually a pretty big virus for these kind of viruses. So if you talk to virologists, they will tell you coronavirus are huge, and they have huge DNAs. Rhinovirus are much more smaller and is simple in their structures than coronavirus. Coronavirus is actually a very clever virus.
Yeah, it's really interesting, because I think for RNA viruses, the average size of the RNA genome is about 9 kilobases, but for coronavirus, it's 32 kilobases. And it's pretty, I don't know, this is amazing biology right here. I know it's we're in a situation where folks are definitely being impacted and our lives are being impacted, but there's no denying that the science of these particles is incredible.
Yeah, yeah, I heard that too, that it really puzzles everybody how this virus can actually exist with such a big RNA molecule inside them and being effective. It's just impressive.
So moving back to the data, we have a question from Galen, which is, for the percentages that are calculated in table 1B, what was the number of subjects tests with and without the masks? Because the sample size seems small.
Yeah, so the sample size are small, so number total is basically the total amount of people who are being tested. So yeah, it's just 3 is 10, and out of those 10, from 3 individuals, they were able to find virus in their droplets, by example. And here you have 11, 27, 27, 11, 27, 32. These numbers for sure are small, and you can see here, even though you see a reduction to 0 for the coronavirus in this row, is still not significantly true. It's like it doesn't reach the statistics to say this is 100% true. It's close enough, but I said, like, in order to make it more robust, you should sample more people. My guess is, well, one thing is just, in order to conduct clinical research, it's not that easy, no? To gather humans who are actually sick, not feeling very well, keep them in their hospital for longer, asking them to do stuff, testing them extensively. It's a hassle to work with people and get bigger and bigger numbers. It's a little bit more complicated. Also, we all get coronaviruses every winter. Is very common, not COVID-19, other kind of coronaviruses. And most of us don't go to the hospital when we get a cold. You have to be pretty sick. So, and I would guess that because this research is so important now, that it's better to publish it as soon as possible so it's readily available, instead of just waiting longer for this important information. Those are guesses. I'm not sure.
Yeah, I think that's probably a pretty fair estimation of why we are seeing so little. What we call in science is N, or N is like the number of data points that you have. Yeah, there's probably a lot of practical barriers to that. And along those lines, we do have a question that asks around what P means on the graphs and the tables. So I don't know if you want to sort of allude to our coveted P in science.
So P is basically it's a number that we use for statistics. So it's not as simple in science. It's not as simple as say, like, oh, I have, I don't know, 10 points here that are above 10 to the 4, and I have 4 here that are below, so this is different. No, we need to have something that is actually telling us this is really, really different and makes sense. And for that, we use statistics. So we use different statistical tests to compare our data, and then through the test, that these are mathematical algorithms, what they do is just basically look at the probability that this is a matter of chances, of this is actually a real difference. No, because you can be measuring something that is just random chances. So for those, you get a p-value that it can be kind of big. So normally in science, we put a cutoff in p-values that are smaller than 0.05. You can even go smaller depending on the kind of data that you're looking for. So that means that out of you have like less than 5% chances that this happens randomly. That's what the p-value is saying. So in this case, the difference here means that you have 7% chances that this is like a random situation that is not actually true. And you put cutoff there depending on the kind of science data that you have. I'm not a statistician. This is a whole different art form, but it's how you validate what you're looking at.
Yeah, and we've arbitrarily set 95% confidence intervals. So we would have a p-value of 0.05 to indicate, or below, to indicate if something is a real change versus a not difference. But this is by no means meant to be sort of like the final anything. It's sort of like, there's a limitation to your p-value. So that might be going a little bit deeper into the weeds, but I think it's important that we also are acknowledging there are limitations to the p-value. And also, I hope all of you will take a statistics class, because this is how life works. Not get rid of calculus in high school and take statistics instead. That's my soapbox, and I'll get off of it right now.
No, I would say it also as a side thing of statistics. You can have good p-values and prove differences, and then you also have to use your brain and your analytical thinking to make sure it actually makes any sense. No, you can have differences that come from completely other reasons and it doesn't have any biological importance at all. So you have to think about the results. It doesn't matter whether you have a number or not. The thing.
Yeah, and actually, so this is something that's under discussion as to whether we should have these arbitrary settings of, the 95% interval to say this is significant, the 99% interval to say this is super significant. But yeah, I completely agree with Francisca in the sense that this has to be a conversation that's had, and we can't just decide on the basis of an arbitrary cutoff. But for the purposes of the research that we do on an average day, and for experiments that have a lot of data points, it's usually quite, it's a very useful metric for us.
Yeah.
I feel like I got a question from Aditi last time as well. The question is, what portion of exhaled air is larger droplets versus aerosols? Do you know that from the data?
I don't remember. I have to admit. Maybe Jeannie, do you remember?
We can share the paper after this. Maybe we can we'll share the paper and we'll answer this on our Facebook stream. So let's get back to that question.
Yeah, it is a good question though.
Yes. All right, so let's move into a little bit more around aerosolized particles. So if aerosolized particles are at 0 when wearing a mask, how are surgical masks less effective than N95 masks? Oh, very nice. I've seen research suggesting that N95 masks don't protect you very well against aerosol particles. How does this square with that research? So I don't know if this is something that you'll be able to answer based on the paper here. And we can certainly point people toward the Ask a Scientist tool, but I don't know, Fran, if you have anything to say about that.
So the N95, they are not 100% covering everything that goes out of your mouth. It's just basically like particles that are finer, like bigger than these 95. I don't the 95 come from somewhere. I don't remember. I actually wear this mask every day, and I haven't looked into that for my research. And yeah, it can be that you have these aerosols coming out, but maybe because the coronavirus is a big particle, it just stays inside, and you don't detect the viral particles in the exhaled breath using the N95. I will say that the N95s for sure are like more protective than regular surgical masks, and that's all I know. I mean, just for wearing them, you kind of know. The N95s, whenever you get I don't think now they are doing it, but I remember when I was when I had to start wearing the N95, I went through a process of evaluation to find the right N95 that fit exactly in my face. And they did a bunch of tests to make sure the exhaled breath and the inhaled breath, and the amount of particles that are coming in, and like, etc. So it's not just a matter of wear an N95 and you're gonna be protected. No, it's a little bit more tricky than that.
Yeah, and if I can add, I know that people, just to your point regarding the fitting, like I saw this article about how a person is fit, in a really serious way, where they have a person wear an N95 and then they put them in a chamber and they aerosolize some aspartame. So, it's that sugar substitute that you can really taste. And, if the N95 mask is not fitted correctly, that person would be able to taste the N95, the aspartame, and they continually go through this process of spraying the aspartame until that person cannot taste it. They do mask sizing and adjustments until that person cannot taste it. And that's how a lot of people are fitting. That's one way people can actually detect if their N95 fit is the right fit. Did you have to go through that, Fran, or when you were wearing your stuff?
It was not that. It was basically a specific N95 brand that has the tubes in, so it measure how, I don't remember very well how much air is coming out, whether it's tight, how I breathe, whether I can smell or feel some stuff. It was I did it at the Rockefeller University because this is just like a kind of like a sad, funny situation that I'm allergic to mice, and I work with mice every day, so I have to wear this mask. But I donated all of my masks to the hospital here, so I don't have any. I have one left that was used.
Yeah, we don't.
Sad reality. Yeah, a lot of people who do particularly rodent-based research do develop allergies at some point, and it gets to the point where it's actually dangerous for them to work. But the previous question is kind of a good segue into the next one, which is that though the surgical masks are effective, if people don't have the proper knowledge of how to fit them, so there is no exposure, what good are they?
I mean, if you don't know how to wear a mask, then leave the N95 to people who actually need it right now, to be honest.
I think this is to do with the surgical masks, though.
Yeah. For the surgical mask, so in the case of the surgical mask, some of us, like by example, I have a few at home, so I'm gonna like rotate through them, and I don't dispose them because we need them. But if you go into the World Health Organization website, you will find a ton of resources of how to actually properly put the face mask, properly wear it, dispose it. Here I put on some of these slides that they have. You have to make sure you're washing your hands before you put it. You put it only grabbing sort of like the side that goes into your ears. Then don't touch it. That's something I see everywhere. People are like doing groceries or on the subway and they just touch it. No, don't do that. No, don't touch it. And then when you want to take it off, you wash your hands first and then you take it off. So right now, by example, I'm not disposing these ones that are actually supposed to be single-use masks because there are not too many available. I'm reusing them in so the standard that the Rockefeller University has right now is that you have to wait 3 days to reuse it, so you are sure that the virus is dead if there is any virus there.
Yeah, and I don't think it's really appreciated that it's not just about wearing your mask, it's also about taking off, like knowing how to take off your mask. And in science, we call that process of putting on donning your PPE and the process of taking off doffing your PPE. And it's really important that you learn how to don and doff. And I will say, just as another sort of element of being on a soapbox, I'm seeing a lot of people wearing gloves, but like going into their pockets and picking up their phone and talking on their phone and putting it to the face and then touching everything, and I just want to make sure that people don't think that the masks and the gloves are gonna if you're not using them correctly, then they're useless materials. And they are kind of limited. So make sure that when you're using them, you know that you're using them correctly.
Yeah.
One thing about gloves we always said was that, especially in our lab, they tend to be bright purple or something else. The one thing that might do is stop you from touching your face, because as you see them, you're less likely to want to at least do that in order to transmit the virus.
That's true.
So in the interest of time, I know there's a ton more questions, and maybe some of these questions we can just note them and try to answer a couple of them in the web archive, or we do plan on creating a little bit of a discussion guide around each talk. So, you know, for those of you who didn't get your questions answered, we'll try to do our best to represent them in the study write-up. But in the meantime, you know, I'd love to hear, Fran, is there anything that you want to share, you know, regarding your experience with this and presenting this paper that maybe nobody asked, or something that, a question that you have specifically that you don't have the answer to, you know, what, you know, where are you along those lines?
So I think, well, I love doing these presentations. I hope everybody really enjoys it. I also learn a lot about sharing of bread in general. It's something that you don't usually like look online. So one thing that like I learned a lot about all these different labs here in the US that are looking into the research of this dynamical process that we go through in our daily lives. And it's amazing. It's amazing how much we shed outside. And I also think that for me, the main question, there were two main questions that I got, like, it lingered with me after reading the paper. One was already asked, which is, what is the infectious potential that these particles have? And I don't know whether we know. So right now people are studying the effects of viral loads and how much you need to get sick. And also, this is not like a super number question. It's very tricky because everybody also has different genes, have different comorbidities, different situations, so it's not that easy to answer. And the other one that I think it is important to recognize is now that most of the countries are asking people to wear masks, and if you don't have access to these surgical masks, because now we are leaving them for medical staff, to wear like a cloth or something like made of mask for yourself. And we don't know yet whether this is 100% like really effective to stop the spreading of the virus. But I think if they tell you to do it, it doesn't harm you. It's not that terrible to go around with a cloth in your like with a cloth mask. You can make them. I mean, now I see in Vogue magazine making them like super cute ones that you can make at home and like put in a lot of effort. I think that's also a main question that we must answer. Also, today is Earth Day. So for me, all the disposable stuff, it still hurts my heart now to see so much waste of plastic. So if the cloth works, I'd rather have that, to be honest.
So before we disappear, tuvimos una pregunta en español.
Oh, awesome.
Dado que estos virus mutan y cambian, es posible que en próximos años los cambios en el virus afectan la capacidad de las máscaras para proteger a la gente, o los coronavirus siempre serán grandes y por lo tanto las máscaras siempre serán igualmente efectivas.
Yo creo que los coronavirus, como es una familia de virus, siempre van a ser así de grandes. Así que de aquí al futuro siempre van a ser efectivos. Tendría que mutar de una forma dramática para que cambiaran tamaño y composición. Y para eso yo creo que después ya pasa a ser otro tipo de virus, como que evoluciona un poco. Y el virus sí muta, de todas maneras, tiene un bajo nivel de mutaciones, pero sí va a mutar, y lo que se espera es que eventualmente este virus pase a ser un virus que va a estar en el fondo en la sociedad humana siempre y no va a afectarnos tan fuerte como ahora, porque la lógica detrás de eso es que en general, si el virus disminuye un poco su capacidad infecciosa y no mata tanto, o sea, se hace como menos agresivo, se va a expandir más. Entonces, al final, los virus menos agresivos se expanden más en la población y le ganan a los virus que son más agresivos, porque esas personas como que se enferman y son aisladas antes y pueden morir antes. Entonces, este virus se espera que en el tiempo sea menos dañino y por lo tanto igual usar mascarillas va a ser efectivo.
Muy
Awesome.
bien.
Thank you.
Yeah, gracias.
So I think you could stop sharing your screen, and thank you again to everybody who joined us for the second installment of D4P, and please make sure that you take our survey. I will email everybody with information about the survey if you missed it, and just let us know how we're doing, or you can email outreach@rockefeller.edu. Thank you again to all of the people who are making this happen, from our friends at Scientists Inc., my colleagues at RockEDU, to Eva and Lizzie from WCMC and Sloan Kettering, and to Fran, thank you. You were amazing. It's such a pleasure working with you. Thank you for always saying yes when we ask you to do stuff for us. It was really, really fantastic.
Thank you. I really appreciate this. If you have any questions, you can also ask me. I think my email is somewhere.
Yeah, we'll share it, and be on the lookout for the archives of the videos for D4P. We are working on getting them online, and be on the lookout. We will be with you again next Wednesday at 3:30 p.m. where we will have a postdoc from Rockefeller talk about the proximal origin of SARS-CoV-2, which basically is demonstrating how we know that the SARS-CoV-2 virus came from a bat. So thank you again. Be in touch. Like us on Facebook. I think I'm supposed to say all of these things. I'm trying to like mimic all the YouTube people that my kids watch. You know, smash that like button or whatever they say. I don't know. Yeah, like us. But although they're saying it for YouTube, not for Facebook. But feel free to like us on Facebook and follow us on Twitter. Follow us on Instagram. We'll have more D4P lovely goodness coming your way in a week's time. So thank you again, and we'll see you soon.
Hasta la próxima.
Chao.
Bye.
Cuídense.